Hello everyone, my name is Mikel Graham and I'm here representing HeliDirect and Horizon Hobby, and today we're going to be talking about lithium polymer batteries or LiPos. Now in the helicopter hobby, most helicopters are electric these days and they are powered of course by our LiPo batteries. So today we're going to be talking about 5 different subjects. We're going to talk about safety, break-in, the care and health, disposal, C ratings, and power. So with that said, let's get started. Let's talk about LiPo safety. LiPo batteries are energetic devices, and I'm sure you've heard many stories of them catching on fire, not just within the hobby, but in consumer electronics. Stories where batteries have caught on fire after a crash, while they were charging, or being completely left unattended. Because of that, you should always have safe practices when handling LiPo batteries. Some simple things here, such as never let the battery get too hot, never overcharge them, don't damage the battery, don't puncture the battery, never charge them unattended, and when not in use, store them in a safe place. Why do we break in our LiPo batteries at all? Well, when LiPo batteries are manufactured, they are manufactured with a chemical stabilizer. This chemical stabilizer allows the battery to sit on the shelf for a very long time with no degradation. The process of breaking in your battery is to break down the stabilizer. Until the stabilizer is broken down, you'll be unable to get maximum performance. So you won't get maximum power or maximum capacity. Remember though, once the stabilizer is broken down and the battery is fully broken in, you've started the clock on the battery's life cycle. LiPo batteries degrade no matter what. No matter how you use them or how hard you use them, they're going to naturally degrade. This is why there's a chemical stabilizer in the first place. Now there are 3 schools of thought on how to break in a battery. One school of thought is to cycle the battery on the charger slowly up and down multiple times. Another school of thought is to beat on the battery as hard as you can to break down that stabilizer as fast as you can. And another school of thought still is to just use the battery as regular and let it wake up on its own. In my experience, having tried the slow method and just beat on it as hard as you can method, I did not see a difference in performance between the two. I would argue that in today's modern world with modern batteries, the method of break-in does not matter much. With that said, there is one thing to remember though. In my experience, it seems to take about 10 to 20 cycles for a battery to be fully broken in. Now, how many cycles it takes for your battery to be broken in is going to depend on the brand, the method you use, and a host of other factors. But generally speaking, 10 to 20 cycles is about how long it takes for a LiPo battery to reach its maximum performance. Let's talk about care and health of LiPo batteries. General rules of thumb apply here. Don't overcharge the battery beyond your manufacturer's specified voltage. Don't over-discharge the battery below 3 volts per cell, and when not in use, keep the battery voltage at around 3.7 to 3.8 volts per cell, or storage charge. Don't let the battery become excessively hot. Try not to use 80% of the battery's total capacity, and never charge the battery unattended. When you are charging, make sure you're using a designated LiPo charger that is capable of balancing the cells. And also, when charging, charge away from any flammable items. When the batteries are not in use, make sure that they're stored in a safe space. Try not to leave your batteries charged any longer than necessary. This deteriorates the battery. The higher the voltage, the faster the battery degrades. I personally do not like to charge my batteries until I'm just about to fly. Generally speaking, my batteries don't stay charged any longer than 30 or 45 minutes. So why is over-discharging the LiPo battery below 3 volts per cell so bad? Well, when the voltage gets below 3 volts per cell, this allows unwanted chemical reactions to occur. These chemical reactions do permanent damage to the battery that impact overall power output and capacity. This is not an instantaneous process though. So the longer the battery is below 3 volts, the greater and more permanent the damage is. So what this means is that if you're flying and you happen to over-discharge your battery, just get it back on the charger, get it above 3 volts, and you should be okay. But if you have a battery that has been sitting for an extended period of time below 3 volts, then you'll need to charge it very slowly to get it above 3 volts again. When I say slow, I mean about 0.1 C. Now, remember, because it's been below that voltage for so long, there's been permanent damage to it, and you're not likely to get the same performance that you had before. So always keep that in mind if you find a battery that has been below 3 volts for any extended period of time. There are a couple things we can do to determine the health of a battery. One of those things is the internal resistance, or the IR. You can find the IRs of your pack using your LiPo charger. Now, there's no rule of thumb here. IRs can vary from brand, C rating, and size of the pack. Higher C ratings and larger packs are going to have a lower internal resistance. This alone is not enough to determine the health of a battery. For example, a large battery with a 20,000 milliamp capacity may have a lower internal resistance than a battery that only has 2,000 milliamps. That doesn't necessarily mean that this battery is healthier than the smaller one. What's more important is that the internal resistances are all in balance with one another. So when you break in a battery, the internal resistance will drop, and then over time will creep back up. What's important is keeping an eye on those internal resistance over the life of the battery. Now, over time, you'll start to notice that the battery is starting to get hotter, and doesn't have the same punch that it had, doesn't have the same power. The capacity is dropping. These are all signs that the battery is on its way out and reaching the end of its life. One other thing to keep in mind is making sure all your cells are in balance. So if you have a battery and most of the cells are between, say, for example, 1 to 1.3 milliohms, but you have one cell that's at 5 milliohms, that's a sign to let you know that that cell is going bad, and unfortunately, that pack is not going to last much longer. So let's say it's clear that it's time to retire your battery. What's the best way to dispose of it? Now, as I mentioned before, LiPo batteries are energetic devices, and you really don't want to just throw it in the trash where it can be damaged or punctured and start a fire. So what's the best thing to do here? First, you want to discharge the battery down to 0 volts. Do this slowly and do not do it unattended. Once the battery has been fully discharged, you can take it to your local battery recycling center where they will dispose of the battery properly. Another option is to check with your local flying field to see if they have a program to handle damaged or dead batteries. So what are C ratings and what do they mean? Within the same battery brand, you'll see batteries with the same capacity and same voltage but different C ratings. In general, the C rating is a measure of the battery's performance. A higher C rating means a battery will perform better. And higher C rating batteries tend to weigh more than lower C rating batteries. So a C rating is a measure of how much current and thus power a battery can deliver. Let's do some quick math. So we have let's do a 6S 5000 milliamp hour battery. Now let's say this battery has a C rating of, say, 20C. So what does this mean? Well, we're going to deal with, instead of dealing with milliamp hours, we're just going to deal with amp hours. So amp hours here is just 5. So we're going to take 5 and multiply it by 20. So we get 5 times 20, and here we get 100, and this is 100 amps. So this battery claims that it can deliver 100 amps of current. Let's do another example. Let's do a 3S 2000 milliamp hour battery, and let's say that this is a 50C battery. So this is going to be 2 times 50, and this is going to be, again, 100 amps. So on paper, this smaller 3S battery is able to deliver as much current as the 6S battery because the C rating is that much higher. Oftentimes, a manufacturer will quote a continuous C rating and a burst C rating. The continuous C rating tells you how much current the battery can deliver on a full charge, so from fully charged to fully dead. Burst current lets you know how much the battery can deliver for either 5 seconds or 30 seconds. Here's the truth about C ratings though. Because there's no standard way to measure C ratings, many manufacturers may have their own way of measuring them. So a 20 C rating from brand A may only be a 5 C rating on brand B. Further, depending on the manufacturer, continuous and burst can have different meanings as well. For some manufacturers, continuous means continuous for 5 seconds or 30 seconds, and burst means just a literal blip on the throttle. It's because of this you should only use batteries from reputable manufacturers. C rating also plays a role in charging. Again, refer to your brand's recommended charge rate. For the longest time, 1C charge rate was the standard for our LiPo batteries, but modern batteries are able to handle much higher charge rates safely. Right now, 3C is a safe charge rate, but there are some brands that claim to be able to handle 12C charge rates. Again, no matter what rate you use, always charge your battery attended. Never leave a LiPo battery on charge unattended, especially if you're using the higher C rates. Now, as expected, the faster you charge and discharge a battery, there is a penalty on the overall lifespan of the battery. However, the penalty of charging at 1C versus 3C at this point in time is pretty negligible. So what does this mean when charging? Well, let's do a little math. Let's say I have a 3S 4000 milliamp hour pack. Let's say I want to charge it at 1C. So remember, we're not dealing with milliamp hours, we're dealing with amp hours. So we're going to take that 4, multiply it by 1, and we get 4 amps. This is the charge rate that you need to use to get 1C. For 2C, it's going to be 4 times 2. This is going to be 8 amps. And for 3C, it's going to be 4 times 3, or 12 amps. Now we can also use this calculation to figure out roughly how long it'll take to charge our batteries. And this is what that looks like. So we're going to do 1 hour divided by 1C. So 1 hour divided by the C rating. In this case, this is going to be 1 hour or 60 minutes. Let's do 1 hour divided by 2C. This is going to be a half hour or 30 minutes. Let's do 1 hour divided by 3C. This is going to be 0.333 repeating, or a third of an hour is 20 minutes. And let's do one more. 1 hour divided by 4C. This is going to be 0.25 hours, and this is going to be 15 minutes. Now, I wanted to show this because, as you notice, the higher rates we go, we start getting diminishing returns. So going from 1C to 2C, well, we've just saved 30 minutes. That's a lot of time. But going from 2C to 3C, we've only saved 10. And then going from 3C to 4C, we've only saved 5. So as the higher your rate goes, you're starting to get diminishing returns. So I mean, what's the difference of really saving, 5 minutes versus 3 minutes or 10 minutes? And at that point, when you're at the really high rates, you're just damaging your battery to save a few minutes. So in my opinion, staying between 1 and 3C is a good balance between time and health of your batteries. So you can actually apply a similar calculation towards your helicopter to determine how many C on average the battery is delivering. Let's go ahead and do an example. Let's take a 550 running a 6S 5000 battery pack. Now, let's say we do a 3-minute flight, and after that 3-minute, we use 4,000 milliamp hours. All right, so bear with me, just trust me on the math, but this is how you do this. We're going to take 60 minutes, divided by the 3 minutes, and we're going to get 20. We're going to take that 20 and multiply it by the amount of milliamp hours that we used in the flight. So we're going to do 20 times 4. Remember, we're using amp hours, not milliamp hours. This gives us the average current throughout the flight. So on average, we're drawing about 80 amps. So now that I have that 80 amps, I can do 80 amps divided by the total capacity of the battery, which is 5, and we get 16C. But wait, 16C, that seems really, really low. I mean, not only that, if we're doing a 3-minute flight and we're taking out 80% of the battery, if you know hard 3D, that was not a soft flight. That was a hard 3D flight. So if that was a hard 3D flight and I'm only drawing 16C, why do I need 20C, 50C, or 100C pack? Well, hold that question because I'm going to answer it in a few minutes. So before we move on, I want to cover some common terminology. You may see something like 3S, 2P. What does this mean? Well, this means that there are 3 cells in series and 2 in parallel. This pack actually has a total of 6 cells, but it only has a voltage of 12.6 volts because of the 3 cells in series. So a LiPo cell only has 4.2 volts. So if we want to get higher voltages, we have to put them in series. So in series increases the voltage. Parallel increases capacity. So let's say I have a cell that has a 2000 milliamp capacity. I want a battery with 10,000 milliamp capacity. What I can do is that I can put 5 of those cells, so 2000 times 5, to get the 10,000 milliamps. But because they're all in parallel, they still only have the same voltage. In this case, this would be a 1S 5P. So it would still be 4.2 volts, but it would have a capacity of 10,000 milliamps. Okay? So that's what that means when you see things like 3S 2P. So what about high voltage batteries? What's the benefit? Well, the main benefit is longer flight time. Because you're able to take the voltage higher, you're able to get a higher capacity for the same size battery. The C rating stays the same. So you can either get a longer flight time for the same weight or the same flight time and save a little weight. Power is everything when it comes to our helicopters. Our nitros can put out around 3 to 4 horsepower, whereas a properly set up electric can do 10 to 15 horsepower. That power allows us to do power-hungry maneuvers without breaking a sweat. And of course, our LiPos are the source of that power. So let's go back to that example I mentioned before about the 550. Remember, we calculated that the battery was only delivering about 16C. Now, I'm going to write down some basic equations here. Let's start with Ohm's law, which is voltage equals current times resistance. I'm also going to write down power, which is current times voltage. Now remember, this 16C corresponded to about 80 amps. So 80 amps. Now I want to calculate the power necessary for the helicopter to fly. We're going to use the nominal voltage here. So, which is for 6S pack is 22.2 volts. So we're going to do 80 times 22.2 volts, which is roughly 1800 watts. Now, I know I'm overestimating, but just for simplicity's sake, we're going to say it's 1800 watts. Now, the thing is, though, all batteries sag under load, right? So, let's say in an ideal world, battery is fully charged at 25 volts, roughly, and it stays at 25 volts for the length of the flight. So what does that mean? That means that if it stayed at 25 volts, and we know we need 1800 watts to fly, that would correspond to 72 amps, an average current draw of 72 amps. Let's say we have a 1 volt battery sag. So now we have, let's say this is 24 volts, assuming same voltage throughout the flight. This corresponds to an average current draw of 75 amps. And let's really drive the point home. Let's say the battery sags as much as 5 volts. So now In this case, battery's at 20 volts, and this corresponds to 90 amps. So what's the point here? The greater the voltage drop, the greater the amps. The reason being is because of this equation. It takes 1800 watts for the helicopter to fly. If voltage goes down, amperage has to go up to compensate. So what does this have to do with C ratings? Well, higher C rating batteries are able to maintain voltage under load better than lower C rating batteries. So what that means is a 100 C rating battery will be able to maintain voltage better than a 20 C battery. So remember, based on the equations that we did back here, the little exercise, that in order to maintain the same power, if voltage drops, current has to go up. So the less voltage drops, the less current has to increase. But why does that matter? Because it is the current, it is the amps that actually create heat. And I'm going to explain that more. So our power systems have some innate resistance to them. The battery itself has some internal resistance. The wires, the ESC, the motor, there's resistance in the power system. This is an important point. Now, for the sake of argument, let's assume that the resistance throughout the power system is constant and does not change. I'm going to make a quick substitution with the equations that we had. I'm going to substitute V equals IR into the power equation. So we have P equals I, substitute in, times IR. This turns into P equals I squared times R. This is a very important result because when current passes through a resistor, it dissipates heat through this equation. So, what does this mean? This means that a small increase in current is squared. All right, so let me give an example. If current goes up by 10%, the amount of energy lost to heat, only heat, goes up by 21%. That's 21% more additional heat that you're just losing, and everything's getting hotter. Now, what happens if current goes up 20%? Well, this corresponds to a 44% increase in heat. That's just everything getting hotter. And the reason why things get hotter is because it has to dissipate that energy. And heat dissipation is a function of the difference in temperature. So in order to dissipate more heat, it has to get hotter. So we have shown through these basic equations that as voltage drops, current goes up. So what does it have to do with C rating? Well, as I mentioned before, higher C rating batteries are able to maintain voltage without sagging as much. That means that as the helicopter gets loaded up, it's able to maintain that voltage and able to deliver that power without dropping voltage and thus increasing amps. So, the higher the C rating, the lower the amps, everything runs cooler, and everything is more efficient. But I also want to make one other point. This is also why the longer you fly, the hotter everything gets. Because remember what I said. As voltage drop, current has to go up to maintain the same power. Batteries, once you start using them, the voltage has to drop. They have to. And so to maintain the same power, current has to go up. So you're drawing more current at the end of a battery, at the end of a flight, than you are at the beginning. That increase in current corresponds to an increase in temperature, corresponds to an increase in heat, corresponds to an increase in temperature. So that's why you want to have a higher C rating battery. Additionally, going back to the point, well, this is only 16C. Why do I need 100C versus 20C? Because the voltage drop can get quite significant under load. 100C is not going to drop as much as a 20C. And because this is dropping so much, combined with the battery being depleted, a 20C battery is going to get much hotter, and your entire power system is going to get much hotter. The other added benefit, this is not a main benefit, but there is an added benefit, you'll actually get slightly longer flight time. And the reason being is because, again, it's able to maintain voltage better. So do a quick thought experiment. Let's say you have two helicopters, weigh the same, they're hovering with the same head speed, under the same load, and you're going to land as soon as your telemetry hits 3 volts per cell. Because the lower C batteries sag more under load, that battery is going to hit that 3 volt limit faster than the higher C battery. So it's not going to be a huge difference. It's not going to be, oh, I fly 3 minutes on a low C battery and I can fly 5 minutes on a high C battery, but there is a slight difference. Because higher C rating batteries are not working as hard as lower C rating batteries, they will actually have a longer lifespan. I'd like to make one last point when it comes to our RC helicopters. When it comes to our head speed, power draw goes up with RPMs cubed. So what that means is a 10% increase in head speed corresponds to at least a 33% increase in power. The reason why I say at least is because that increase in power is also going to correspond to an increase of heat. So your overall power draw from the battery is going to increase significantly. All in all, you want to get the highest C rating that's appropriate for your application. If you're a sport flyer or doing low head speed, then you don't need to get the highest C rating and you can save a little bit of weight, but you still want to get a C rating that is appropriate, that doesn't tax your batteries and your power system. If you're doing hard 3D, of course you want to get the highest C rating available to you. There is a penalty in terms of weight and price, but it's worth it in the long run. Your batteries will run cooler, you'll get slightly longer flight times, and your batteries will last longer. Alright, so we covered a lot of information and I hope it was informative for you. If you have any questions or comments, please leave them below. And like this video, subscribe to HeliDirect, Horizon Hobby, and my personal page, which you can find below. Thank you for watching. Be safe and have fun, everyone.